So the very first thing I'm gonna do on this one is multiply the 3 and the -7. That's minus 21. And then I'm gonna use this rule that the root of A times the root of B is the square root of A times B. So what I want to do is write square root of 45 times 12. So that's 45 times 12. I'm gonna just try to do it this way really quickly. 45 times 10 is 450. 45 times 2 is 90. So that's gonna be 540. That's 45 times 12. But the question is 540, does 540 have a perfect square root factor? Since 540 is a pretty large number, it may be hard to make a list of all the factors. So I'm gonna approach it in a little bit of a different way. And I'm gonna take 540 and I'm gonna make the prime factorization tree. So it's even, so actually, since it's divisible by 10, that makes it a little better. So it's 10 times 54, then 2 and 5. 9 times 6 is 54. So I'm gonna do 9 and 6. 9 is 3 times 3. 6 is 2 times 3. So what I'm gonna do is go about it sort of, the more arithmetic kind of way. It's not as slick as knowing what all the factors are, but this is gonna work. So I'm gonna show you here in a minute. So 2 times 2, that's this guy and this guy. And then there's 3 3s, 1, 2, 3. And then, so that takes care of those, and then there's a 5. And I can always double check. 2 times 2 is 4, times 3 is 12, times 3 is 36. And that's 36, this is 15. 36 times 15. Just want to double check that I get 540. Okay, perfect. So what I'm gonna do is for every pair, I'm gonna take out 1 because that's what we mean by the square root. So for those 2 that I just circled, I'm gonna take out 1. And then for the 2 3s here, I'm gonna take out 1. And since I can't make pairs anymore, the rest is gonna stay inside. And that's a 15. So my final answer then is the result of -2 times 2 times 3, which is -12 root 15. And that's how you simplify this type of radical expression.